Okay, so by now you must have heard about DeepSeek, and especially DeepSeek-R1 is the model that created all the market hype. So what is DeepSeek-R1? So I'll try to explain that without any hype, without any fluff. So this is no nonsense explanation of DeepSeek-R1. Um, so there are two types of large language models. Um, Chat models and reasoning models. In chat models, we expect them to give reply to our question. In reasoning models, we don't want the reply only. We want the whole reasoning chain that led to that response. Okay. Um, so in a way, chat models are system one models, which basically means that they are very fast at inference. Um, it's like system one is like when we ask a question 1 plus 1. Humans don't need to think about that; they can just reply. System two is processes which need explicit thinking, step by step thinking. For example, when you're planning for a vacation, it's a system two task. You have to ask many questions, you have to think what are the preferences, who is traveling, how many people, what is the budget, and so on and so forth. That's a system two task. Uh, it's very common these days that some of the models hide all those thinking steps and just share the final response. OpenAI O1 does that. But anyways, the reasoning models do that detailed analysis before they share the final answer with the user. In terms of famous models, so a famous chat model, we are all aware of GPT-4, Claude, Llama. Granite is the model by IBM, and DeepSeek V3 is a model by DeepSeek, which is a chat model, and DeepSeek-R1 is their reasoning model. I must say, OpenAI O1 was the first successful reasoning model demonstration that we saw. People were trying it before, but O1 was the first successful reasoning model. They are also known as inference time scaling model because they are slow at inference. They generate a lot of words or tokens during inference stage before they come up with the final answer. But O1, OpenAI in general, all the models from OpenAI, they are proprietary, they are not open source, the weights are not shared, we don't know how they were constructed, we don't even know how many parameters they have, so everything about them is kept proprietary. Okay, so let's play with the DeepSeek a little bit. So let's first start with DeepSeek V3, which is a chat model. Okay, let me ask it a simple question. So of course this is a simple question, so we expect the right answer, and it gave it very quickly. 1 plus 1 equals 2. That's it. That's your answer. Okay. Let me ask the same question to R1, which is a reasoning model. Okay. So now with reasoning model there is a thinking process which can be very long. It analyzes the problem from different aspects before it answers you. So basic arithmetic, maybe they're looking for a joke answer because it's such a simple question that it make a model doubt my intention. And then uh, let me confirm, in standard addition 1 plus 1 is definitely 2. So it basically have this self-reflection kind of self-correcting kind of behavior and very long um, reasoning stream um, before it reaches the final conclusion, which in this case is the same, it's 2. So this is the difference between a chat model and a reasoning model. Chat models basically gives you the answer with a very minimal kind of explanation. On the other hand, these reasoning models or inference time scaling models can give a long analysis before they come up with the final answer. And that also helps them improve the accuracy significantly. So if OpenAI O1 model already showed a working reasoning model, then why there is so much hype about DeepSeek-R1? So this is a technical perspective. Of course, you can think of it from different like financial perspective and so on. But the reason why there is so much hype is because this is the first time anyone has open sourced the full pipeline of how to build reasoning models. So DeepSeek now allowed anyone who have the right skills and resources to build their own reasoning models. And then not only that, they open source the weights of their models. So now you can deploy it in your own server so that the data never leaves your premise, and you can do a reasoning model which is very, very powerful. And they also release small size reasoning model. These are fine-tuned versions of other open source model like QN model and Llama models, and they can even run on your laptops without GPUs. Okay. And the algorithmics advances are also significant. They reduce the hardware usage, of course, reduce cost. They're very efficient at inference time. So there is a series of very innovative papers that were coming out of DeepSeek since early last year. However, we just recognized them after the release of R1, the true potential of all those advancements. They, however, did not talk about the data. They did not talk about open sourcing the data. They did not talk about the money spent on iteration before the final run. So, of course, final run is not everything. The whole learning process, the whole skill development happens much before the final run. So the cost that was used to do all those iteration is not discussed in the paper. So some of the articles circulating on social media are calling this fake news, fake. But in reality, all the technical leaders agree that this is an amazing progress by DeepSeek, both in terms of algorithmic progress and open sourcing everything. So there is no doubt that it was a big leap by DeepSeek. Two things that can be discussed, in my opinion, are the cost. So $6 million is the cost of the final training run. But what is the real cost? They did, of course, hyperparameter tuning. They did experiment with different data. So what was that run? That is not being shared. And actually no one shares that, to be fair with them also. Everyone shared the cost of the final run. So this is okay. And when it comes to data, there is again some misunderstanding that they copied the whole reasoning chain by OpenAI O models. But the issue is OpenAI O1 models, O3 model, they don't share the full reasoning chain. So there is no way DeepSeek can copy the whole reasoning chain. That being said, there is a value in distilling OpenAI models just for question answer pairs. But there is no proof right now whether DeepSeek have done that or not. So we will have to wait a bit more before they tell us anything. Okay. So this is a nice image I found. Someone who computed the real cost. So of course the final training cost 6 million, but what is the cost before that? So it comes out to be much higher. Can we now discuss what is special about R1? The only issue is that we have to understand what DeepSeek V2 and V3 are before we can discuss R1, because R1 is based on DeepSeek V3. V3, V2 are chat models by DeepSeek. You can see the results on the upper right corner, and you see they're much better than their competitor or competitive models. V2 came in May 2024, I believe, and V3 came in December 2024. It's 671 billion model, and 37 billion are activated at a given time, which means it's a mixture of experts. So it's a combination of many smaller models that are activated. Different models are activated at runtime, bringing the activated token to 37 billion. So this is a base model for R1, V3 is base model, and some of the innovations that were done in V2, V3 are first, a very successful use of mixture of expert, although others were using it before. For example, Mixtral is a mixture of expert model, but they were not very successful with it. Okay. It's a auxiliary loss-free load balancing, so they did not add any loss terms in the cost function. There is multi-head latent attention. We'll discuss that. A new RL algorithm called GRPO. Multi-token prediction. So all these innovations were done in order to reduce the hardware cost and make it much more efficient. And then during training of V3, they actually distilled a little bit of R1. So R1 is dependent on V3, and then a little bit of R1 was distilled, or R1 was used to create some reasoning thoughts, and that was used in the training of V3. So it's a chicken and egg problem. So they actually iterated probably between V3, train V3, then use it to train R1, and then use R1 to improve V3. And they mention it as internal model. So at that time, R1 was not released. So they were already experimenting with reasoning models in December. They also did innovation in 8-bit precision training of the pre-training of the model, and then very efficient compute and communication interleaving so that the GPU can be used to the full capacity. So on the right hand side, upper right side, they show some of the innovations. What one is a mixture of expert, and then there is multi-head latent attention. We'll discuss MLA in the next slides. So I have explained what self-attention is in my earlier talks, especially reasoning with LLMs talk, so you can see that on my channel. If you look at the upper right corner, a mixture of experts, so it's not new, but the way they use it is very efficient. So even the Mixtral model by Mistral company, they are a mixture of experts. It means that there is no single model. There are many small models that are used, and they're selected by a router at the runtime. So if you see here, there are green colored shared expert models, which are always selected, and there are blue rooted model. You can think of them as specialist. For example, there can be a small model doing chemistry better, doing math better, so they can be selected by the router at the inference time. So ultimately what happens is that the overall number of parameters that are activated reduce significantly, giving large benefit at the inference time. And they did it in a unique way where they did not add any loss term in the loss function during training time. So this gave them a big advantage over non-MOE models. Then multi-head latent attention. So multi-head attention is always there in transformer architecture. So if you look at the leftmost figure, that is multi-head attention. We have queries, keys, and values. You can consider queries to be a question. For example, a book you want to find in a library. Keys, you can think of it like shelf in the library, and value is the actual book that you want to get from that shelf. So there are different versions of this to make it more efficient, and you have to, in order to make this efficient, you have to keep cache these keys and values. Okay. So for example, there is a grouped query attention, there is multi-query attention, but the innovation that comes from DeepSeek is called multi-head latent attention, where they compress the whole key and value pairs into a very compressed low rank matrix space, and then it is projected into the normal key value space for computation. And this is similar to what LoRa does for model training. It compresses the weights into a low rank space and only chain that low rank space. So this is what is happening here, and this gives a big boost in compute resource usage. When we are pre-training the model, what we are doing is we are training it to predict the next token. Let's think of token as a word for now. So we are given the previous words in a sentence or a paragraph. We just ask it to learn how to predict the next word. But next word sometimes does not give so much information. What about predicting next several words or the next full sentence? That is what they're doing. They're not in DeepSeek paper, V3 paper, they are now predicting multiple tokens and then training the model to not only generate the next token, but like consecutive, like the next substring or the next sentence. Okay. This definitely next word might not give enough information, but next sentence definitely give much more information, and this also results in a performance boost for the network. Now we can discuss R1, which is a reasoning model. You can see the results here. As I said, so it's not only about the final result, it's about the whole reasoning chain that these reasoning models generate. And you can look at the results. The rightmost in each category is DeepSeek V3, which is a chat model, and leftmost is DeepSeek-R1, which is a reasoning model. And I must say, I got a lot of help from the slides that I mentioned here. It's a YouTube video on the DeepSeek-R1. So thank you for the maker of the video. So this is the whole pipeline, and it's actually what DeepSeek guys open source for everyone so that they can now build their own reasoning model if they want. Okay. And this is pretty amazing. So they start with DeepSeek V3, which is a chat model. Okay. Then they take few thousand chain of thought examples. Chain of thought examples means like example where they had question, they had few reasoning steps, and then they had the answer. Okay. They curated it with human in the loop. So humans looked at it, they corrected if there was some mistake, and then that data was used to fine-tune DeepSeek V3. Fine-tuning means that it became much better at solving the training data that was shown in this stage. Okay. This was a good model to start reinforcement learning. Reinforcement learning, as we understand it, basically aligns the model into the weak signals that we give the model. So we don't have to label the data, but we have to give some weak signals which data is better than the other. Okay. Humans are very good at doing that. We actually can tell which data or which answer among two do we like more, but we are very bad at actually quantifying that. Okay, so we are bad at giving scores. I wonder how my high school teachers used to do that, but anyways, humans are not good at scoring. So what they did is they took math and code data, means questions, and they use some reward function, and that's another thing that's pretty amazing. They use rule-based reward. I'll discuss that in my coming slide, but that's a very do remember it. It's very cool. So this resulted in a very strong reasoning model. However, the model lost some of the general capabilities in producing very fluent natural language and so on and so forth. So what they did is they added some new 200K non-reasoning examples. For example, question, summarization, simple multi-hop chatting, and so on and so forth. And then they also filtered the reasoning model that they have created. They filtered around 600K very quality reasoning traces. These reasoning traces are long thinking process before reaching the final conclusion. So they sampled that, and then they used both of them to fine tune again. And this brings back those general capabilities, and they, according to their term, it bakes in the reasoning capability of the model. Okay. They did a few more tricks because the model was trained on mainly on English and Chinese language data. So they did a few more tricks. where they added some kind of reward to reply only in one language, not mix the languages with each other. And then the last step, they did GRPO, reinforcement learning algorithm again, and they get their final model. In the last stage, they added math data, code data, and general type of reasoning. General type of reasoning can have anything, basically, any question answer that require some step of reasoning. For example, what is the river? What is the largest state bordering Mississippi River? Okay, what is the largest river in the world? And so on and so forth. It requires some kind of reasoning. So, and finally, they get DeepSeek-R1. Another amazing thing they did is they distilled those 600K examples from GRPO after GRPO first stage, and they created a distillation of some famous models like Quen models and Llama models in different sizes, like 1.5 billion to 70 billion. They created those models and they open source for us. So all DeepSeek v3 is open source, DeepSeek-R1 is open source, the whole pipeline was open source, the smaller models were open source after distillation, and they say that it's much better to distill these smaller models from a bigger model instead of training these smaller models directly on this given pipeline. So that's amazing find, and this is actually what created so much hype in the community. So the first stage of fine-tuning is what they call cold start. As I said, so they use few thousand chain of thought examples after human curation, and they did it because they wanted a strong model which provides a stable foundation for performing reinforcement learning, and this gave the model some basic reasoning capabilities. With few chain of thoughts, the model was able to understand what reasoning is all about. They actually talk about another paper. They open source another model called DeepSeek-R1. That's an amazing, again, advanced, like DeepSeek-R1 0 model was only trained on reinforcement learning. There is no cold start. There is no fine tuning. Okay. And that model is very good at reasoning, but they mention clearly that it lacks some generalization ability. So it was having some problem. That's why they went to cold start and combination of fine tuning plus RL. As I said, they present a new reinforcement learning algorithm. It's called GRPO, Group Relative Policy Optimization. So I have discussed how alignment works in my talk called Taming Large Language Models. So please see that in my channel. But here, this is a specific algorithm which came in DeepSeek math paper. So this was published in April of 2024. What they do is that for each question, so in alignment and reinforcement learning, we have to give the questions, okay? So they ask the model to generate 64 samples for each question, and then they pick which one of them are correct or incorrect according to some rule-based reward functions, okay? I'll discuss those functions in the next slides, but you have to, like, out of these 64, you have to assign the score somehow, let's say that. Okay? And then you compare each sample, which is better, which is which gets lower rank, okay? And then what they do is they basically compute a mean of those all those responses, and then they increase the probability to generate good answers for all of those responses, and they reduce the probability of generating bad answers for all the low performing answers that they have, okay? So instead of, so what people used to do is they used to generate many samples, okay? Given a question, they used to generate many answers and then just pick the best one and improve the model to produce that best answer. It was pretty inefficient, and now what they're doing is they basically sample it to generate 64 answers. They use all the 64 to update the gradient. Okay, so it's drastically becomes much more efficient to to train the model much more faster. They did it on 144K chain of thought examples from different math dataset and different code dataset. But as I told you in the flowchart, they lose some of the reasoning, some of the general language capabilities by doing this. So coming up with a good reward function is a huge problem. Okay, usually the reward functions are trained. They are either called the outcome reward models, which looks at the final answer and it assigns the reward, or it's process reward model, which can assign reward to each reasoning step also. Okay. However, they found that they can live without both of them, both ORM and PRM. They don't need it. In the first stage, at least, they just use accuracy reward and format reward. So accuracy reward means that for math problem, they just check if the answer matches with the gold answer, they keep the whole chain. Similarly, with the code problem, they can execute the code and they can see if the answer matches with what the LLM came up with, they keep it. Otherwise, they give it a very low reward. Okay. And format rewards. Format rewards means that it needs to follow some format. I have given this prompt at the top. Like this is the prompt that was given to the model: generate thinking process and answer with the proper format, with the tags and everything. If the formatting is correct, it gets higher reward. If the formatting is wrong, it gets lower reward. Okay. Again, it's pretty amazing. These rule-based rewards are all they did in the first step of RL. No outcome reward model, no process reward model. Then they did rejection sampling, where simply they sampled 600K of reasoning traces. Again, it simply means that they, given a question, they sample the model several times and they pick the best one out of all those. So that's how rejection sampling works. So they did 600K created by rejection sampling, and then 200K they got from somewhere, some other sources about the data for writing or summarization or factual QA and stuff like that. Maybe RAG, they got it from other places. And this 600K is the data that they use to basically distill R1 for other smaller models, Quen or Llama. Then this is the second fine-tuning stage, where they try to restore general capabilities. And then the second RL stage, where they basically apply a new reward model. These reward models actually teach what is a harmful outcome, what is more helpful. So they try to increase helpfulness, reduce harmfulness, okay, for the model. So this is what happens in second stage. In second stage, they use both rule-based reward model and outcome reward model. And rule-based is applied to math and code, and non-rule based ORM is applied to general reasoning data. And this is the result, which is pretty amazing. If you look at comparison to OpenAI O1 on these benchmarks, these are different benchmarks dealing with math, school, high school level problems, software engineering problems, many different reasoning domains like chemistry, physics, biology, and so on and so forth. And it's doing pretty well compared to O1, sometimes better, sometimes a little bit lower, but overall it's as powerful as O1 for reasoning tasks. The question that people ask me is, should I be concerned when I use DeepSeek? Is my data being stolen? So the issue is that DeepSeek does keep all your input prompts, just like everyone else do. So if you don't want to give DeepSeek your input, then you should also not be okay with giving it to anyone else. So um, another thing is that in order to use DeepSeek for your commercial application, there are deployments of DeepSeek because DeepSeek open source their model, so all the weights are available. So many cloud-based services like IBM Watson X, Microsoft Azure, NVIDIA can be used to host. They actually provide the hosting of DeepSeek models in their cloud services. So in this case, the data will stay on their servers, not go to DeepSeek. So it's as safe as other models that we commonly use. So conclusion, it's amazing because they published a report on how to build reasoning pipeline. They open source the models, R1 model, they open source other digital models. There are a lot of algorithmic innovations which helps in compute, cost. For me, the amazing find is that simple reward model can be very helpful. Okay, so and they came up with new RL algorithm also, which is very efficient. Okay, and then they also tell us that okay, doing too much RL on rule based can break your general capabilities of the model. So that's why you need to do some fine tuning steps and you need the cold start. So that's another very interesting find. Thank you. Don't forget to follow me and subscribe to the channel. And I'm planning to make another video very soon where I'll talk about DeepSeek-R1 for non-technical people so that they can understand the amazing advancement done by DeepSeek. Thank you.